The USS Ashland, LSD-48, 16,000 tons of American steel and determination floating in the Gulf of Aden. April 10th, 2010, 0500 hours local. I'm standing watch in Main 2. That's the aft engine room for you land lovers, monitoring gauges on the boiler when general quarters sounds.
General quarters, all hands man your battle stations, all hands man your battle stations.
And when GQ sounds on a warship, everything changes instantly. Every sailor knows their battle station. Every system has redundancy. Every role has a backup. The entire ship becomes one coordinated organism with 400 souls working as one. You know what that sounds like? Kubernetes, the control plane that keeps containerized applications running exactly the way you declared them. Rescheduling, healing, scaling, and routing automatically. This is faith, freedom, and tech. I'm Scott Houghton, Navy sailor, DevSecOps engineer, cloud architect. And today we're talking about how the principles that kept a warship running in hostile waters can keep your containers orchestrated in production. Welcome to episode 3 in our deep dive tech series. Kubernetes like a sailor, military precision meets container management. Before we dive into the tech, let me paint you a picture of that morning. The Ashland wasn't just any ship. She's an amphibious dock landing ship. Think of her as a floating garage that you could flood her well deck and launch small boats. We had Marines aboard as part of the 24th MEU. We were supporting the global war on terrorism, operating out of Little Creek, Virginia, but deployed to the Horn of Africa. Now, I need you to understand something about naval engineering. The Ashland had 2 engine rooms, main 1 forward, main 2 aft. Each engine room had 2 massive cold peel stick diesel engines, the boiler and an eval. As an engineman, I stood watch on all of it. Boiler ops, engine ops, sound and security watch. We followed the EOSS, the Engineering Operating Sequencing System. Think of it as our run books, our standard operating procedures. Everything documented, everything repeatable, everything observable. Sound familiar? It should. That's your infrastructure as code. That's your observability stack. That's Kubernetes. But let me tell you what happened that morning when 7 Somali pirates decided to test the wrong ship. So there I am, monitoring steam pressure and water levels on the boiler. Get one thing wrong, and everything's over. The USS Ashland, steaming through the Gulf of Aden, Pirate Alley, they call it. These waters, 330 nautical miles off the coast of Djibouti, Africa. They're hunting grounds for Somali pirates. And at 0500, they found us. Or what they thought was a cargo ship. See, from a distance, in the pre-dawn darkness, an LSD might look like a merchant vessel. These pirates, 7 of them in a skiff. They saw what they wanted to see, a target. They opened up with small arms fire on our port side, likely AK pattern rifles based on what we heard over the net from the aft watch. Big mistake. Huge mistake. The Ashland's response was immediate, orchestrated, just like a properly configured Kubernetes cluster responding to an attack. Our MK38 Mod 2, that's a 25 millimeter chain gun. Return fire, 2 rounds. The skiff lit up like a bonfire, caught fire, and started sinking. But here's where it gets interesting from an orchestration perspective. When general quarters sounds, I'm relieved from my boiler watch by another engine seamless handoff, 0 downtime. That's your rolling updates in Kubernetes terms. The system keeps running while personnel, or in Kubernetes, pods, rotate positions. I haul ass topside. My battle station, one of the 50 cal machine gun mounts. But by the time I get there, the engagement's nearly over. The gunner's mates, with their 25 Mike, had already handled business. The pirate skiff, destroyed, on fire. 7 men in the water. Well, 6. One didn't make it. And here's where the Navy orchestration really shines. We deployed RIBs, rigid hull inflatable boats, to rescue these pirates. Yeah, you heard me right. The same men who just shot at us, we pulled them from the water. Why? Because that's what professionals do. That's what discipline looks like. That's a well-orchestrated system does. It handles the unexpected with grace. We brought 6 of them aboard, gave them medical treatment. They became evidence for NCIS. They ended up in federal court in Norfolk, Virginia. Multiple defendants received life sentences. One got life plus 10 years. Play stupid games, win stupid prizes. But let me connect this to what you're dealing with in your infrastructure. Kubernetes orchestration is exactly like running a warship. Let me break this down for you. First, the node structure. On the Ashland, we had divisions: engineering, deck, operations, supply. Each division had specific responsibilities, but worked together. In Kubernetes, you've got your control plane and your worker nodes. The control plane is like the bridge and CIC, Combat Information Center, making decisions, maintaining state, coordinating action. The worker nodes, that's your divisions, actually doing the work, running the containers, executing the mission. Second, redundancy and high availability. The Ashland had 2 engine rooms for a reason. If main 1 goes down, main 2 keeps us moving. That's your high availability control plane setup. That's your replica sets ensuring pods stay running, even when nodes fail. When I stood boiler watch, I wasn't alone. There was always someone ready to relieve me, someone to back me up. In Kubernetes, that's your horizontal pod autoscaler, your readiness and liveliness probes, your pod disruption budgets. Let's talk about the EOSS, Engineering Operational Sequencing System. Every procedure, every valve lineup, every emergency response was documented, step by step, no ambiguity. You know what that is in Kubernetes? Your manifests, your Helm charts, your operators. Infrastructure as code that ensures consistency every single time. When we needed to start a pump, align a system, respond to a casualty, we didn't guess. We followed the EOS. When you deploy to Kubernetes, you don't manually configure your containers. You declare the desired state and let the orchestration handle it. The parallels are absolutely uncanny. Now, let me tell you about observability. On a warship, everything is monitored. Every gauge, every alarm, every system has indicators. We had watch logs where we recorded readings every hour: temperatures, pressures, RPMs, fuel levels, tank levels. In Kubernetes, that's your Prometheus metrics, your Grafana dashboards, your centralized logging with Elk or Splunk. You can't manage what you can't measure, whether it's steam pressure or container performance. But here's what separates good orchestration from great orchestration: understanding failure modes. On the Ashland, we drilled constantly: fire drills, flooding drills, man overboard, general quarters. We practiced failure because failure in combat means death. In Kubernetes, you need the same mentality. chaos engineering, deliberately breaking things to see how your systems respond. Netflix Chaos Monkey, that's just a Tuesday on a warship. Every sailor knows their damage control responsibilities. Every sailor can fight fires, stop flooding, provide first aid. In Kubernetes terms, every node should be able to handle multiple workload types. Every pod should be disposable and replaceable. You don't have specialized snowflake servers. You have cattle, not pets. Just like sailors, everyone's cross-trained. Everyone's replaceable. The mission continues regardless of individual failures. Service mesh. Let me blow your mind with this comparison. On the Ashland, we had something called sound-powered phones. No electricity required. Direct communication between spaces, even if we lost power. That's your service mesh. Istio, linkered, providing communication between services independent of the application logic. Though, unlike sound-powered phones, a mesh still requires compute. But the idea is the same. Communication that's independent of your application code. The phone talker circuits connected, damage control central to every major space. The service mesh connects every microservice. Both provide redundant communication paths. Both operate independently of the primary systems. In traffic management, we had that too. Darken ship protocols where we contained every light to avoid detection. Traffic patterns for flight ops. Routing for boats coming in alongside. That's your ingress controllers, your load balancers, your traffic policies. Let's talk about security. Force protection on a warship is layered. You've got lookouts with binoculars, radar operators tracking contacts, deck watches controlling access, armed roving patrols, multiple layers, each one backing up the other. Kubernetes security works the same way. Network policies controlling traffic between pods, RBAC managing who can do what, pod security admission. That's the modern replacement for the old pod security policies. That got removed in Kubernetes 1.25. These define what containers can do. Secret management protecting sensitive data. Remember, treat secrets as sensitive data and turn on encryption at rest for etcd, or wire up to your cloud KMS. Service mesh providing MTLS between services. Defense in depth. Whether you're protecting a warship from pirates or a cluster from hackers, the principle is identical. You know what Romans chapter 8, verse 28 says? And we know that in all things, God works for the good of those who love him, who have been called according to his purpose. That pirate attack, it taught me about orchestration before I even heard of Kubernetes. Those years in the engine room, following procedures, standing watches, responding to casualties, God was preparing me for a career I couldn't have imagined. The discipline, the systematic thinking, the operational excellence, it all translates. And here's something else the Navy taught me. You're only as strong as your weakest link. One sailor not doing their job can compromise the entire ship. One misconfigured pod can bring down your entire application. That's why orchestration matters. That's why standards matter. That's why discipline matters. Practical implementation. Let me give you some real Kubernetes wisdom from a sailor's perspective. First, namespaces are like departments on a ship. Engineering owns their spaces. Deck owns theirs. Operation has CIC and radio. Use namespaces to separate concerns, control access, limit blast radius. Second, labels and selectors. On a warship, everything is labeled. Every valve, every switch, every breaker. You can find anything in the dark because labeling is consistent. Your Kubernetes labels should be just as systematic. Environment, application, version, owner, consistent labeling enables powerful selection. Third, resource limits. A ship has finite resources: fuel, water, food. We track consumption religiously. Your containers need resource requests and limits. Don't let one pod consume all of your CPU and memory, like one department hoarding all the fresh water. Config maps and secrets. On the Ashland, we had unclassified and classified materials, different storage, different handling, different access controls. Config maps are your unclassified configuration. Secrets are your classified data. Treat them accordingly. Helm charts, there are deployment packages. When we're pulled into a port, we have standard loadouts: ammunition, fuel, supplies, standardized, versioned, repeatable. Helm provides the same for your applications. And operators, custom operators are like having specialized teams. The BBSS team that handled boarding suspicious vessels. The flying squad, that's the firefighting rapid response team, purpose built for specific missions, automated response to specific conditions. Let me tell you about incident response. When those pirates attacked, our response was immediate because we trained for it. We didn't have to think. Muscle memory kicked in. Your Kubernetes incident response should be the same. Runbooks for common failures, automated responses where possible, clear escalation procedures, regular drills to maintain readiness, and postmortems. In the Navy, we called them after action reviews. No blame, just lessons learned. What went right, what went wrong, what we will do differently. Every incident makes you stronger if you learn from it. Here's the thing about that pirate attack: it wasn't heroic, it wasn't like the movies. It was disciplined professionals executing procedures they'd trained for. That's what good Kubernetes orchestration looks like. Not heroics, not firefighting, not staying up all night fixing things. Professional, systematic, orchestrated responses to predictable events. The pirates thought they were attacking a cargo ship. They found out different real quick. Your applications might face attacks too. They probably will. DDoS, injection attempts, resource exhaustion. Will your orchestration respond like a cargo ship or a warship? Wrapping this up, the USS Ashland still serving. Whidbey Island class was once slated to serve through about 2038, though decommissioning plans have shifted over time. Ashland's still active, shifted home port to San Diego in 2023. That's the power of good engineering, regular maintenance, and systematic operations. Your Kubernetes clusters can have the same longevity. Not the same clusters, obviously. You'll upgrade, you'll migrate. But the principles, the practices, the disciplines, those endure. From a faith perspective, 1 Corinthians chapter 14, verse 40 tells us, all things be done decently and in order. That's orchestration. That's Kubernetes. That's how you build systems that survive contact with reality, whether you're defending a warship from pirates or your applications from failure. The principles are universal: defense in depth, systematic response, observable operations, continuous improvement. Some practical takeaways for implementation. Military grade Kubernetes. 1. Start with security. Network policies from day one. RBAC before you need it. Encryption by default. 2. Make everything observable. Metrics, logs, traces. You can't manage what you can't measure. 3. Practice failure. Chaos engineering works. Disaster recovery drills work. Game days where you deliberately break things. 4. Document everything. Runbooks, procedures, architectural decisions. Your future self will thank you. 5. Cross-train your team. Everyone should be able to deploy, debug, and respond to incidents. No single points of failure. Look, I know this episode had some intense moments. That's the reality of military service. That's my reality. But I'm not going to sanitize it completely. These experiences made me who I am. But here's what matters. Those experiences, that training, that discipline, it made me who I am. It prepared me for a career in DevSecOps. It taught me orchestration before orchestration was cool. God uses everything, even pirate attacks, even failed restaurants, even struggling with faith. It's all preparation for the mission he has for you. Faith, Freedom, and Tech releases episodes throughout the week. Next Tuesday, we're diving into multi-cloud architecture, building bridges, not walls, multi-cloud native design. If this episode helped you understand Kubernetes better, share it, like us on social media, follow us. Some junior engineers needs to hear that about orchestration. It isn't magic, it's discipline. Some veteran needs to know their military experience translates directly to DevOps. Until then, keep your clusters orchestrated, your pods running, and your faith strong, even when the pirates come calling at 0500. This is Scott Houghton reminding you that whether you're orchestrating containers or defending freedom, discipline beats talent every single time. Booyah and Semper Fi to my Marine brothers who were aboard that day. Keep building, keep believing, keep orchestrating, and God bless. I hope you enjoyed this episode of Faith, Freedom, and Tech. If you did enjoy this episode, or if it helped you, like, subscribe, and leave a review. It helps others find us. Share this episode with someone who needs it. We're building a movement here. Find me on X at faithft_podcast or wherever else at Faith, Freedom, Tech. Check out faithfreedomtech.com for show notes and more. Keep building, keep believing, and God bless.